Hello, let's look a little bit further at the distance formula. All right, so we have already stated the distance formula D between any 2 points with coordinates x1, y1, and x2, y2 is given by the equation D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's an example. So it says, we're going to do an example really quick. The distance between 2 points, 2, 3, and negative 4, 6. So that's to be my first point and my second point. So I am, just for the sake of clarity, that's my first point, and that's my second point. So plugging that in, my x2 would come from this point here, so that would be negative 2 minus my x1, which is minus 2, which is 2, squared, plus my y2 would come from here, would be 6, minus my y1, which is 3, squared. So negative 4 minus 2 is negative 6 squared plus 3 squared. Again, we're following the order of operations. Negative 6 squared is 36 plus 3 squared is 9. So 36 plus 9 is 45. I'm going to have to come over here. Excuse me. So we'll say D is equal to the square root of 36 plus 9 is 45. Put that in my calculator and evaluate that even further. And let's do that. Put it in decimal form. So the square root of 45 is 6.7. Okay. Let's try another one. So again, we'll say that this is our first point and this is our second point. So we have the square root of our second x, which is negative 3, minus 1 squared plus 0 minus 2 squared. Following over order of operations, we get negative 4 squared plus negative 2 squared. So I get 16 plus 4. So 16 plus 4 is 20. And the square root of 20 is 4.47. Alright, so we can also use the Pythagorean theorem. So if we have actual points, like for example here, I want to find the distance between this point and that tree at a point, I can find my distance. So I can count actually. So we can count 1, 2, 3, 4, 5, 6, 7. Notice I have no clue what these points are, right? I have 1, 2, 3, 4, 5. I'm just finding the distance. So according to the Pythagorean theorem, this is my right angle. I want to find the distance. So that's going to be leg squared, which is 5 squared, plus my b squared, or my other leg, which is 7 squared, to my c squared, or my distance squared. So that's going to give me 25 plus 49 is equal to c squared. So I get 74 is equal to c squared. I don't want to find c squared, I want c, so I need to take the square root. So that's 74 is equal to, the square root of 74 is equal to c. And I get 8.6 equal to c. Oops. Let's just try, well, we can doesn't matter, we could try both of them. We have 1 and 0.1 and 0.2. So my distance is x2, which is my -8, minus 12 plus 3 minus 3, -20 squared plus 0 squared. So I'm just going to put plus 0. I already know what that is. So this is definitely on a straight line for us. So 20 squared, or -20 squared, is going to turn out positive, of course. We're talking about distance. This has to be positive. I know that I'm going to get 20, right? You get 400, and the root of 400 is 20. Let's do the second one. So let's say that's 0.1 and that's 0.2. So again, I have 5 minus 0 plus 12 minus 0 squared. And I get 5 squared plus 12 squared, just because I'm running out of space. So I get D is equal to the square root of 25 plus 12 squared, which is 144, which is equal to the square root of 169. And the square root of 169 is 13. Okay, another one with our graph. So here I have my graph, and this time it's going in the opposite direction. I'm just going to go ahead and draw my line. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, I don't have to know the coordinate points. I just want to find the distance. So that's going to be leg squared plus leg squared equals, we'll call it D instead of C this time. I hope that's okay and it's not too confusing. So we have 9 squared plus 9 squared equals D squared. And I get 81. So that gives me 162 equals D 162. And that's going to give me D. And I get 12, 7, 3. Here's my distance between the school bus and this house is 12.73 units. And I hope that this helps.